Okay, welcome back. We're at the final steps of getting this 300B amplifier ready to fire up and put on the scope. I wanted to go over the final bit of heater wiring that I installed this last couple of days, and then we'll get to putting this thing on the scope and running it through its paces after we check the voltages. So here are the two heater pins, and each one of these goes to one side of this potentiometer. Then the center of this potentiometer comes over and goes over to this pin on this tag strip that goes to the positive of this bypass cap. This wire here goes down to one side of the 880 ohm cathode resistor that's mounted on the top side of the amplifier, which I'll show you here in a minute. The other pin from the cathode resistor comes out here, connects to this pin, which also is the negative side of this bypass capacitor, and then it goes to this blue wire over here that goes over here to the star ground. This is the grid of the 300B, and it's connected through this coupling capacitor to the plate of the second stage of the driver tube. Then we have this grid leak resistor that 270K that comes across here and connects to this ground terminal where the input tube grounds are all centrally located, that then also runs over to our star ground. And that's the last bit of the wiring. So now I'm going to hook the power up, some dummy loads, and we're going to show you how to do the voltage testing before we jump into putting it on the scope. Okay, I'm going to run you through my step-by-step process on powering up an amp for the first time and checking voltages and making sure that everything's good to go before we put this thing on a scope, and make sure we don't have any issues with the voltages inside the amp or something not being wired correctly. So, first thing we want to do is power on the amp. And the first voltage we're going to be measuring, since we know that the heaters are working right, is the voltage on the plate of the output tube. And here we're slowly seeing the voltage come up. There's 30 volts, 40 volts. We just want to make sure we don't have some outrageous number on the plate. And I've got the variac set on about 80 volts. And we're seeing 250-ish, climbing on up. 260. So then we're going to go down here and see what kind of voltage we have on the cathode. And 38 volts. We're all looking good. Over here we got about the same voltage. Very similar voltage there. Then we're going to jump up here. This is the B plus going to the input tube. Well within reason. Nothing outrageous on the plate. Going to the first stage of the driver. And this is the plate for the second stage of the driver, which is also within reason. So we're going to go ahead and crank the voltage up to about 100 volts and see what we have there. Here's play the driver tube. We're at 380 on the cathode. We got 56, just about where we were expecting. Again, 380. And 60. We'll jump over here to the B plus for the input tube and just 238. Grid of the first stage. Or not the grid, the plate of the first stage. Sorry about that. 69, that's looking about what we expected. And 69. We're looking for about 430 volts on the plate of the output tubes and around 70 volts. So we're going to go ahead and turn it up to right at 120 in. There's 415. It's 415. 67 volts on the cathode. 66 volts on the cathode. The B plus to the input tube. 261. This is the plate and the grid. It's the plate on the first stage and the grid of the second stage. Got 73 volts. 73 volts. So we are good there. Now we're going to check the cathode of the second stage. 77 volts, which is what we want to see. You want to see the cathode being about 4 volts more than the grid so that we have a negative bias on the grid of the second stage of the driver tube. And the same here. We got 76 versus 73. You just want to see 3 to 4 volts difference between the grid and the cathode of the second stage of the driver to make sure that we have a negative bias there. And now I'm going to switch down here. So here we got it 120 volts in. Turn back to DC. Get our ground connected. This will be our final voltage reading. And there's 428 on that plate. $426 on that plate. We have 68 volts on that cathode. 69 volts on that cathode. All of these are right where I was expecting to see them. We've got almost 75 volts on that plate in the grid. In this cathode. 78 volts. So we've got the right bias there. First stage plate, the second stage grid, 75, 78. All these look exactly where I was hoping to see them. So now we know we've got the correct bias on the driver tubes and on the output tubes. The last thing I'm going to check is the cathode on the first stage, which is 1.46 on that one and 1.47 on that one. So that's the bias that's being put on the grid of the input tube, first stage. So now we know that all the voltages are right in line of what we wanted to see. Now we're ready to put this thing on the scope. I will advise too, before you power up a tube amp, even without a signal going in, I would connect some dummy loads to the speaker jacks, just in case there was some sort of internal oscillations that we're not aware of yet, that we're not going to stress out the output transformers and damage them. So make sure you get some dummy loads to use when you're doing your testing, and we'll show more of that in just a minute. We're going to do a little handheld video of this section to show you the test equipment that I use when I'm running my gear through its paces after the voltages check out. This is my old Tektronix scope, a 2235. It's a 100 millihertz oscilloscope, which is plenty for a tube amp. I'm not even sure you can buy a scope that would be too low a millihertz to work with a, or megahertz to work with a tube amp. So I really like these analog scopes. This one's got 2 inputs and more dials than I need. Not going to go into how to operate a scope. There's videos for that, but I will show you like the basic setup to get ready to test the amp. And here's my little signal generator. It's an old Tima audio generator. It's a 1 megahertz. It's got an attenuator, an amplitude dial, and the outputs are just a little banana jacks on the front. Got these buttons here to switch between the different ranges. It does a fine job. It does a sine wave and a square wave. So it's really useful for doing basic testing on an amplifier. This is one of my dummy loads. That's the little probes I use. They're just little cheapy, bought them off eBay probes. Here's the little RCA jack that runs over to the signal generator to insert the signal into the amp. And that's basically my setup. Again, make sure you use the isolation transformer when you're using a scope. I'm done with using the Variac for right now. And here's our amp, ready to be tested. And I don't know if I've showed you yet, there's where the cathode resistors for the output tubes are mounted. Right there in the middle behind the big output tubes, and you can see the vent holes around them. And I did that so the heat from these cathode resistors wouldn't be trapped underneath the amplifier. And again, the input jacks are on the side. Here's the volume control that everybody said they liked. We went with that one. And these are a couple of H8HC 6S and 7 Russian clones. And I have had this amp running, and I tube rolled a little bit, and these seem to really sound the best. And they're very inexpensive. They're about $10 a piece. So that fits right in with our budget. And then we have a TAD tube amp Doctor 5AR4 rectifier tube. So let me get the camera set up. Let's get the scope set up, and let's get rolling with this test. Okay, now we're ready to start testing this amp to make sure it's doing the basic stuff amplifiers are supposed to do before we hook this thing up to some speakers and make sure there's nothing crazy going on with it. Basically what we're going to do is feed a 1 kilohertz signal into it and then look at the waveform that comes out of the output transformers to see if it is at least similar to what we're injecting into the front end of it. So before we start testing, every oscilloscope has a test port. This is a 0.5 volt at 1 kilohertz. This knob here sets the volts per division. That's 0.2 volts. That's 1 volt. 0.5 volt per division is a good place to start. And this knob over here on the far right, it sets the time between the divisions. So that's at 1.1, that's 0.2, that's 0.5. That shows a whole waveform, and that's usually the setting that I use. So now we want to set our waveform generator to put out the same 1 kilohertz. And it is. We can set it down to a 0.5 volt if we want. And that's very similar to what we were seeing coming out of the test port on the oscilloscope. But really what we want to do is simulate what a normal line voltage would be for whatever your line output is. Most of the devices I use are around 1 volt peak to peak. And so that's what we set the initial sine wave to, is a 1 volt peak to peak sine wave. So at this point, we turn on the amplifier. And we have the other scope lead connected to the output jack on the same channel that we have the input signal being fed into it. And have the volume turned down. That switch there shows both channels. So as our tubes are warming up, we'll give it a minute for the amplifier to stabilize a second. So I'll trim this out of the video. Okay, the amp's warmed up good enough now where we can do our first test pull. And we have it set on 5 volts per division on the output with a 0.5 volt per division on the input. So when we have the waveforms aligned on top of each other, the output will be at 10 volts out. So we're slowly going to turn up, and that's looking pretty good. You stack them on top of each other, they're pretty darn close to being the same to each other. I did note that it does seem to be, actually those look really close to being the same. So we're going to go ahead, and that right there is like half volume on the knob. But as we turn the volume up more, that's right when we start seeing how the bottom waveform, the bottom of that waveform is starting to clip down here. And that's only 5/8 on the volume knob. So we've got enough drive here to drive the amp to clipping at 5/8 volume. And then if we turn it up more, you'll start seeing the top clipping as well. So we do have a little asymmetrical clipping. And I'm not sure yet if that's on the driver side of the amp. Very well could be. But from what I'm seeing here, up to half volume should sound really good. When you start seeing a waveform that looks like that, when they're right aligned exactly with what's coming in, it's going to sound good. So then the next test we do, we're going to inject a square waveform in, and and we want to get it at 1 volt peak to peak as well, like that. And then I'm actually going to offset this up here, and then offset this other one down here, and then that's coming up on half volume, and there's half volume. And it looks very similar, which is really good to see. There's a little bit of ringing on the front end, you can see over here. But this line is basically really level, and they're really squared off sharply, which is a sign this thing's going to really sound good. So I'm ready to put this thing up on some speakers and hook up a CD player to it, or maybe even my turntable, phono stage, and see what this thing sounds like. Till then, we don't really know what we're working with. There'll be another video after this one where I start really diving into tuning on the amplifier, looking at how to deal with this little bit of ringing we're seeing here, which is probably these lower cost output transformers. I do need to look at, with the scope, the output of the driver tube and see if that's where these waveform problems are coming from, or if they're in the output tube stage, but that's for another video. I still have to install my milliamp meter in the top deck of the chassis, and of course put my Skokie Design logo on it, but I may save that till after I get the amp tuned up. For now, I'm going to really try to tune it to these really inexpensive tubes. I think that in fitting with this budget build, to put $500 300B tubes in it, or $150 rare dual stock 6S and 7 tubes would really be defeating the purpose of what we're trying to do here. Usually when you see people talking 300B tubes, they insist that you got to have $1,000 output transformers and gold-plated speaker cables and $5,000 power conditioners and all that kind of stuff to enjoy them. And that just, I don't think, is the case. I think there's a way to enjoy the quality of a direct heated triode amplifier without spending a fortune. And that's what I've tried to do here in this video. So look forward to doing some more tuning on this amplifier. Probably going to be a week or so. I want to listen to it some, do some tube rolling, and start really diving into tracing the waveforms inside the amplifier to figure out how to get the best sound that I can get out of a low-cost 300B amplifier. So we're not done here, but we are ready to hook this thing up and listen to it and let these tubes and coupling capacitors burn in and give this thing a chance to kind of settle in, and then start doing some tuning on it. If you like my videos, please subscribe to my channel, like the video, and stay tuned for more 300B fun. Have a nice day.